Hello, calculus fans. So the series where we're summing 1 over n squared plus 1 should remind us of the convergent p-series, the sum of 1 over n squared. Intuitively, we should believe that these series really ought to behave the same. When you have large values of n, the terms are very close to each other, so what you're adding should not be very different. The reason this is the case is because 1 over n squared plus 1 is smaller than 1 over n squared. Remember that if you make the denominator smaller, it makes the whole fraction bigger. That inequality is going to let us put a bound on the partial sums of sum of 1 over n squared plus 1 using the partial sums of 1 over n squared. Now we know that the partial sums of the sum of 1 over n squared converge, so too must those of the sum of 1 over n squared plus 1. So to codify this, what we're going to have is the comparison test. And so let's suppose that the sum of a sub n and the sum of b sub n are positive term series. We cannot use this if either series has negative terms. If the sum of b sub n is convergent and a sub n is smaller than b sub n for all n, then the sum of a sub n converges. On the other hand, if the sum of b sub n is divergent and the a sub n's are bigger than b sub n's for all n, then the sum of a sub n diverges. So in order to use the comparison test, we need to have a known series of the sum of b sub n for the purposes of comparison. We'll often be able to use p-series or geometric series to make these comparisons. Okay, that's all for now.